You have all been cartographers just now, okay? Now this is interesting. This is still not the heading. Cartography is not the heading, okay? I love to do this with my classes all the time. I say, I present a problem, okay? And I dislike giving the solutions quickly because then if you have a problem and it gets solved for you very fast, it's kind of like you never get to struggle with it and you don't learn very much from it. So the way I say it to my classes is I let it simmer. I let it simmer. So it's like a little problem sitting in your head. Now here's what's really interesting to me. Okay? Everyone was okay with 3 colors. I mean, Australia was 3 colors. No problems. Okay, so you could have made one just like Australia and it would have been alright. You were okay with 4 colors as well. I saw lots of beautiful 4-color maps. So to go from here to here, no big deal. But then, even with some fantastically complicated maps, I'm yet to see a map that requires 5 colors. And people came to me and said, here's a 5-color map, and every single one I've been presented with so far, I've been able to color with 4 colors. Now, here's the thing. Hang there for a second, because we're going to run out of time, and I would love for you guys to see the whole point of this, okay? This is a map of Europe. People who are good with geography can help me with this. This is the most obvious one. Italy going up. Switzerland going up. Germany. Poland in the middle. Czech Republic. Austria. I think this is Slovakia and Slovenia. And Hungary. Good. Okay, now. All right, I'll come and have a look at it in a second. Shh. Color this with me. Color it with me, okay? How many do we need? What do you want me to color Germany? Red? Red? Okay.
Because it's communism.
No, it's not.
Germany was never communist.
Clearly not a history student. What should be my next red country? Italy?
Yes.
Okay, next.
Hungary.
Hungary? Can I color any more red?
No.
No? Alright. Another color. What should I start with? Poland. What next? Austria? Can I do any more in green? What do you want to be blue? Which one?
Do the 3 S's.
The S's? All the S's. Let's make all the S's blue. That's easy. And then my last one, 4. Now I didn't design this map. This is actually Europe, right? Now this is very interesting. You've designed maps. The world has maps, and they all seem to cap off at 4 colors. Okay? Now why is this? This is mysterious. This, by the way, this is your heading. If you want to put one in now, the heading is the 4-color theorem. You see, now you see why I couldn't name it before, right? The theorem is, no matter what map you present, so long as it's in 2D, okay? You don't ever need more than 4 colors to color it. Never ever. Now, if you have a coloring for it, I can suggest a different coloring with just 4 colors, okay? With just 4. Right? Now don't forget, we don't mind points, it's borders. Right? It's borders that cause a problem. Now, really interesting. It was 1852. 1852 when this 4-color theorem was proposed. And it's very interesting. It's intensely interesting for 2 reasons that I'm interested in. Okay? Number 1, it got proposed in 1852. How long do you think it took them? Like, people draw maps for a long time, right? How long do you think it took them to prove this theorem? It has been proven. What would you guess? It doesn't seem complicated. Like, it's not like it's a 17-color theorem, right? It doesn't seem like it's that big a deal. Guess how long? 100. More than 100 years it took them. More than 100 years, okay? So there's the first interesting thing. Remember I said, think deeply about simple things, right? This is simple. And you can make up even simpler ones. Okay? Secondly, how did they do it? This was the first, no exceptions, major mathematical proof that was proven with computers. And as a result, people rejected it. They said, this is not a proof, right? I can't see the logic. A computer's done it. I disagree. Okay? Lots of people disagree with it for many years. Okay? Now, the question is, why? Why is it true? Okay, well, here's what I'm going to suggest and let you have a think about. This is my final party thought for you. Okay? Have a look at this map over here. How many colors can we do it in? Well, already based on this, you already have a number, but let's just try it out. Okay, I'm going to do it in a particular way, actually. I'm going to do it like this. I think I can do it like this.
I would call the outside of these.
I'm going to do this one green. I'll do this one in green as well. Okay, now, have a look at this map with me. Again, another 4-color map. But here's the important thing. I know it doesn't look like it. But maybe you can tell by the way that I slowly went about it. This map is Europe. Okay? Now, on what basis do I justify that it's Europe? Well, let's think about this. Have a look at the map that I drew. Now, a lot of you guys drew maps with just straight lines, right? Now, I know this looks more mappy, because, you know, it's all jagged and stuff. But, like, if I straightened out some of these borders, it wouldn't matter. It wouldn't change the problem. If I straighten this out, they still have to be different colors. And if I straighten this out, and on and on and on. If I straighten them all out, you end here. Okay? Same arrangement of colors. Okay? So we have a word for this. We call these two maps homeomorphic. This is an important word. You should get it down. Okay? Homeomorphic. What it means is that, do you remember in year 7, we had a look at transformations. Do you remember transformations? There are 3 kinds of transformations. Do you remember what they are? See if you remember. As a class, I'm sure we can. Yeah, one? Turning, so that would be rotation.
Yeah.
Okay, give me another one.
Reflection.
Reflection, that's flipping. And translation, what's translation? It's just, sliding it around, okay?
What is the word again, please?
Okay, so oh, you mean this?
Yes.
I'm going to tell you in a second. So transformations means you can do all these 3 things and it stays the same. Homeomorphic means not a transformation, but a deformation. You see, we've squeezed and we've squashed it and stretched it out, but it's still the same map. Now this is simple. You can see it with this, right? And any map like this, only 4 colors. Just one last pair of words for you to get down. You learned this under the heading of geometry, okay? But this idea here, this idea of homeomorphic maps, deforming things and them still staying the same, is not under geometry. It's under a topic called topology, right? This is the study of shapes that have to they're rigid and they have to stay put. But this is the study of spaces that can be moved and shifted. Okay?